Van der Waals forces are forces of attraction between neutral particles. Neutral particles can be molecules with a covalent bond, such as hydrogen chloride or oxygen molecules. Van der Waals forces arise due to the formation of dipoles. A dipole is a molecule with relative opposite charges at the ends. Charges are formed due to the displacement of electrons in a covalent bond. The dipole can be permanent or directed. A permanent dipole is called a molecule formed by atoms with different electronegativity. For example, hydrogen chloride molecules have a permanent dipole. Since the electronegativity of chlorine is higher than the electronegativity of hydrogen, the total electron pair is biased towards chlorine. The chlorine atom carries a relatively negative charge, while the hydrogen atom carries a relatively positive charge. Dipole-dipole coupling occurs between permanent dipoles. Since all hydrogen chloride molecules have relative charges, different molecules are attracted to each other by opposite charges. A dipole can also occur in nonpolar molecules, where the atoms have the same electronegativity. For example, in binary compounds, as in an oxygen molecule. Electrons in molecules are in constant motion, so at some moments the electron density on one atom is higher than on another. This creates an induced dipole. An induced dipole of one molecule affects the electrons of neighboring molecules, creating polarity. Induced dipoles are attracted to each other. These interactions between molecules are called London dispersive forces. They are weaker than dipole-dipole interactions. Permanent and directed dipoles can also interact with each other. Such interactions are called inductive attraction. For example, between molecules of hydrogen chloride and oxygen molecules. This attraction is also weak and unstable. Van der Waals forces are very weak compared to other existing bond types. This explains the low boiling points of covalently bonded compounds. Many substances with van der Waals interactions are gases.